Hello Honors Geometry students, welcome back. Today we're going to look at composition of transformations, which is really just a fancy way of saying we're going to do more than one transformation to a figure to get to our final destination. Alright, so here's our entrance question. It's asking us to reflect over the x-axis and then apply that vector. So pause the video, do that, and then we'll compare. Okay, pause. Alright, now, so let's compare. First thing that we need to do is reflect over the x-axis, and that's this guy here, the horizontal piece. And if we're reflecting, we want to count out the same distance on both sides of our mirror. Here we go. So we have C prime, D prime, B prime, A prime hanging out here. All right. When we apply a vector translation, remember the first number indicates the x change and the second number indicates the y change. So we are going to move 10 units left, as indicated by the -10, and we will move 3 units down. So to make this a little easier on myself, I'm going to copy that and paste it. All right, and I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the left, and 1, 2, 3, 1, 2, 3 units down to get to my final destination. And we'll name that A double prime, B double prime, C double prime, D double prime. All right. So that's essentially what we're going to be doing today, is applying more than one transformation to a single pre-image to get to our final destination. And as we are doing this, we are going to focus in on our rigid transformations. Rigid transformations, remember, mean same size and same shape. And our 3 rigid types of transformations that we've been talking about in this unit are our translation. Remember, that's our pick up and move, our rotation, which is the twist, and the reflection, which is our flip or mirror image. Okay. Earlier this year, we talked about a non-rigid transformation. Okay, so it's the same shape, new size, and we talked about that earlier this year with dilations, making things bigger or smaller by the same scale factor. All right, and that's going to result in similar figures. All right, so composition of transformations. This is going to be 2 or more transformations performed on a pre-image that result in our final image. All right, and there's one that's one combination that's pretty common, and it's a combination of a reflection and a translation, or a translation followed by a reflection. And that has a special name known as a glide reflection. And it is a composition of a reflection and a translation. Okay. In this particular instance, the order doesn't matter. So if you look at our little sample up here, we have our blue shape resulting in our green shape. Same thing happens, we end up in the same location. So with a glide reflection, we're doing a translation and a rotation. It doesn't matter if you flip first or move first, it's going to be the same. But typically, order is going to matter. All right, Theorem 3.1 from our textbooks. If we have a composition of reflections in 2 parallel lines, so we have 2 parallel lines. Okay, remember, we might mark those up with some arrows. If we reflect over 2 parallel lines, we start with the yellow guy, we end with the red guy. Take a guess, what do you think that's going to be? Okay, that's right. Hopefully you said a translation. So if you do 2 reflections over parallel lines, the result is just a single translation. Okay. Theorem 3.2 says, if you are going to reflect over intersecting lines, so line L and M intersect at this point. If we start with green, flip it over line M to get red, and then flip it over line L to get blue, what happened to get from our original to our new? And essentially what happens is that we are rotating. Okay, and this would be our center of rotation hanging out here where those lines intersect. But a composition of reflections in two intersecting lines is a rotation. All right, and then moving on. Theorem 3.3 says, in a plane, two congruent figures, okay, can be mapped onto one another by a composition of at most three reflections. So that means that no matter what, we can always get to from one figure to the next by at most three reflections. If they have the same orientation, okay, so if we name our two figures like ABC, ABC, and we're going clockwise for both, that would be the same orientation, you can map it with exactly two reflections. Okay. If they have opposite orientation, and remember opposite orientation, so we start with triangle ABC, and now we have triangle ABC but going the other way. Okay, so if they have opposite orientation, we might need to use three reflections. It's going to be an odd number of reflections, either one or three. All right, so we're going to practice doing some of these combination of transformations, and we're also going to practice writing a single rule. All right, so in example 1, we're going to deal with just a single point. So we have A hanging out at 1, -3. Okay, we are first going to do, so we're going to do a glide reflection. So first, we'll apply this translation. So we're going to take our x-coordinate and add 2 to it. And we'll take our y-coordinate and subtract 1 from it. And when we do that, 1 plus 2, that gives us 3. -3 minus 1 gives us -4. Same thing as moving right 2 units, down 1. Okay, so here's our A prime. We are now going to reflect over the x-axis. So here's our x-axis. Okay, we can think about our mapping where xy becomes x -y, or we could simply count. And here we're hanging out 1, 2, 3, 4 units below the x-axis, so we'll count up 1, 2, 3, 4 units above the x-axis to get to our final image at A double prime, hanging out at 3, 4. All right, if we wanted to write a single rule for this, okay, the first part was given for us. So xy undergoes the translation with a mapping of x plus 2, comma y minus 1. And now we need to reflect over the x-axis. And I wrote this down when we were talking about how to reflect. And our reflection over the x-axis says that we're going to leave the x-coordinate the same. So I'll leave that as x plus 2. But we're going to change the sign on the y-coordinate. Now here's where you have to be careful. When we're changing the sign on the y-coordinate, notice that I'm throwing parentheses around that whole thing. Okay, so when I throw parentheses around that whole thing, that negative, it's like multiplying each term by a -1, so I have -y plus 1. So one rule would take xy and map it to x plus 2, comma -y plus 1. Okay. Example 2. Okay, now we're going to deal with a line segment. C is hanging out at -1, 3, and D is hanging out at 3, 5. And again, we're going to do a glide reflection, and then a reflection over y equals x. So our glide reflection, this time it's in terms of translation notation. So we are going to move right 2 units, as indicated by the positive 2, and down 1 unit, indicated by the -1 in the y position. All right, so I might choose to take this CD, move right 1, 2 units, and down 1, and that becomes my C prime D prime. Okay, I now need to reflect over the line y equals x, which remember is this line here, where all my x and y coordinates are the same. The rule for that is we take xy and we flip the coordinates, turn them into yx. So C prime currently is hanging out at 1, 2. So C double prime is going to be at 2, 1. Okay, D prime is hanging out at 5, 4. So D double prime hangs out at 4, 5. So C prime, D prime is hanging out here. All right, if we wanted to write one single rule, okay, we would start with xy gets mapped to. All right, since the glide was listed first of right 2 down 1, I would add 2 to my x and subtract 1 from my y. Okay, then we do our mapping of our reflection over y equals x. And remember, when we did that, the whole x and y coordinates swapped. So right now, my whole x coordinate is x plus 2. My whole y coordinate is y minus 1. So I'm going to have those flip-flop. And so I have y minus 1, comma x plus 2. So xy, as one mapping, gets mapped to y minus 1, comma x plus 2. All right, last one. Okay, now we're going to take it into a triangle. So A is hanging out at 3, 1, B is hanging out at 1, 5, and C is hanging out at 5, 3. All right. Let's see. It says graph the image of ABC after the composition of transformations in the order that they are listed, and my list has disappeared. So let's do this list. So the first thing that we're going to do is we are going to do a 90-degree rotation. And remember, if I don't specify otherwise, that means that it's about the origin. It's also going to be counterclockwise. And our second step is going to be to reflect over the x-axis. Okay, so starting with first, a 90-degree rotation, our mapping that we learned about earlier takes xy and turns it into negative yx. They flip position and the first one changes sign. Okay. When we reflect over the x-axis, xy gets mapped to, and here our y coordinate changes, gets mapped to x negative y. All right, so we can choose to either perform each of these individually, or we can choose to write a single rule and just have to graph one more shape. And since I'm feeling kind of lazy, I'm going to write my rule first and then apply my my composition of transformations. All right, so the very first thing that I need to do is to rotate 90 degrees. And the mapping is essentially done for me. It's just the 90-degree rotation mapping. XY gets mapped to negative YX. Okay. Once we've done that, it's our job to reflect over the x-axis. Okay. And what happened here, we look at our x and y coordinate, and the only thing that happened is that the second coordinate, the y coordinate, changes sign. So in this case, the value in the y coordinate is x. Seems goofy, but that's what's there. And we're going to change the sign. X is positive, so we're going to make it negative. So xy is getting mapped to negative y, negative x. Okay. So A was originally hanging out at 3, 1. So A double prime, okay, to get from xy to negative y, negative x, I'm going to have those coordinates switch spots and change their sign. So 3, 1 becomes negative 1, negative 3, and that's where A double prime would hang out. B was initially hanging out at 1, 5. To get to B double prime, we switch the order and we change the sign on both. So 1, 5 becomes -5, -1. Okay, and then last but not least, we have C is hanging out at 5, 3. To find C double prime, we switch the order of the coordinates and change the sign on both. So 5, 3 becomes -3, -5. And we connect. Okay. And we need to kind of verify, make sure that what we did is looking okay. So does it look like we rotated 90 degrees and reflected over the x-axis? Okay, so one of the first things is anytime we reflect one time, our orientation should be reversed. So ABC, when I list that, notice that that's going clockwise. Now ABC is going counterclockwise. So I have reversed orientation. And I think it looks pretty reasonable that I have rotated. Okay, so I'll just copy this and paste it. It seems reasonable to me that I've rotated this 90 degrees somewhere over here, and then did I flip it over? Okay, and it seems pretty reasonable to me that that's what happened. All right, your job for now is to check out the Composition of Transformations worksheet either in Notability or on ClassKick, and then there's a short 4-question formative for you on Blackboard to check in. For the rest of the week, we have our review as well as our summative. If you have any questions, please reach out. I'm here to help. Hope all is well. Talk to you later. Bye.